All right, so in part 3, we did our subnetting looking at the number of hosts we wanted per subnet. But what if instead they asked you how many networks you wanted? So let's say you were given a Class C address like 192.168.10.0. And they asked you to subnet that into 6 subnets. All right, how do we go about that? We know how to do it if we were given 6 hosts. All we would do is work out how many bits we needed to get to 6. Make those bits 0, the rest of the bits 1, and we'd come up with a subnet mask of 248. You can try that on your own if you want. Make sure you arrive at 248 for 6 hosts per network. All right, but that's not what we want right now. What we want is 6 networks. Right? So the procedure is exactly the same with one difference. All right, first thing you do is work out how many bits do I need to get to my 6 networks, right? And I need 1, 2, 3, right? That's 4 plus 2 plus 1, right, which is equal to 7. Right, in actual fact, it's 0, 2, 7, which accommodates our need for 6 networks. It actually gives us 8. Remember, you're not starting at 1, you're starting at 0. So 0 to 7 actually gives you 8 networks, right, which accommodates our need in this particular case. And just remember, if we use 2 bits, we'd only get to 4, 0 to 3, right? So we needed those 3 bits. All right, important to look up here and see that all your network bits come before your host bits. All right, so these 3 bits, because they're 3 network bits, those 3 bits actually need to be up here, 1, 2, 3. All right, and everything else is 0. 0, 0, 0, 0, 0. So that's the only difference in the calculation here. What we're doing is we're taking the 3 bits to make up our number of networks that we need, right? And we're moving them to the higher order. Why? Because all our network bits come first in a subnet mask, and that is followed by our host bits. So essentially what's happened is these 3 bits have become 1s. Right, 1, 1, 1. Right? And 128 plus 64 is 192 plus 32 is equal to 224. So our subnet mask here very simply becomes 224. 255, 255, 255, 224. Again, procedure is exactly the same. The only difference when you're calculating networks is because they're network bits, right? They go on the left-hand side, right? Up here. All right, so I'm going to give you a few examples again, and you can try those out, and we'll see how we go. Okay, so these are the 3 examples you're going to try and work out. Right, 10 networks, 7 networks, 24 networks. What subnet mask would I require? All right, so you can pause the video now, and when you come back, we'll go through the answers for these 3 questions. All right, so the first one is 10 networks. Let's have a look at how many bits we need to get to 10. 1, 2, 3 takes us to 7. 4 plus 2 plus 1, not enough, so we need to go 1 more bit. Which is 8. 8 plus 4 plus 2 plus 1 is equal to 15. All right, that's more than enough for our 10 networks, so that works. Remember, these are 4 network bits, and network bits are always on the left, which means these 4 bits actually go up here. 1, 2, 3, 4, and whatever's left become our host bits, which are 0, right? So our subnet mask here becomes 128 plus 64 plus 32 plus 16, which gives you 240. Obviously, if it's 0, 0, 0, 0 is 0. All right, so that gives us 240. Right, and our subnet mask here becomes 240, right, with these 4 bits becoming your ones. 1, 2, 3, 4. All right, and that's 240. All right, B is an interesting one. All right, B is 7 networks. Now to get to 7, I need 1, 2, 3. All right, that gives us 0 to 7. 4 plus 2 plus 1 is 7, which accommodates for our 7 networks. Now in modern networks, this would be fine. All right, however, if you're running some older routing equipment on your network, older routers couldn't use the first and the last subnet, which means this would actually leave you with 1 to 6 or only 6 subnets, right? So you've got to be very careful here. If your network is using modern routing equipment, and I'm talking about anything designed in the last 15 to 20 years really, you really should be fine with using the first and the last subnet. All right, so we're going to imagine for our purposes that our network is running modern networking equipment. As a result, we have our 7 networks accommodated by 3 bits. Right? If you remember from the 10 networks, right, we needed an extra bit, but here we only need 3. Those 3 become network bits, which means they move up here, 1, 2, 3. Everything else becomes 0 or host bits. Now, if you're running an exam and they don't specifically tell you that you're running the latest routing equipment, right, you should actually err on the side of caution. So, if I was actually writing an exam and the question said, I need to create 7 networks, but didn't and told me that the network was running legacy equipment, right, meaning equipment that might be outdated, right, I would probably actually answer the question by using 4 bits. All right, so this is a bit of a tricky situation. If you do get it in an exam, just be careful with the wording of the question, right? As I said, if you're running legacy equipment, right, on the side of caution, right, go the extra bit. But let's, for our purposes, imagine that we are running modern networking equipment, in which case we only need 3 bits. Those 3 bits, remember, are network bits because we're looking at 7 networks. So those 3 bits go up here, 1, 2, 3. Whatever's left becomes 0, right? And our subnet mask becomes 128 plus 64, which is 192, plus 32, which is 224. Right? So up here, what we should have is 224, and that's what it looks like. All right, 24 networks, pretty straightforward. If I want to have a look at 24 networks, right, all I need to do again is work out how many bits I need to get to 24. 4 takes me to 15, and that takes me to 31. Right, that's 0 to 31. Right, which accommodates for my 24 networks. Again, these 5 bits are network bits because we are looking at 24 networks. Because they are network bits, they are on the left. Right. 1, 2, 3, 4, 5. Whatever's left become your host bits, right? And if you add that up, 128 plus 64 plus 32 plus 16 plus 8 will give you 248, right? So if we look up here, this should change to 248 with your 1, 2, 3, 4, 5 bits over there. All right, and it's that simple, right? So now we've looked at how to calculate the number of networks. We've looked at calculating the number of hosts per subnet, right? What we're going to look at next is working out the subnet ranges. So it's all well and good to know that the subnet mask in this case is 255.255.255.248. But where does the first subnet start and end? Where does the second subnet start and end? How do I know if 2 hosts are on the same subnet or whether they're on different subnets?